truly our honor to have you, Peggy, as our second Fireside Chat keynote speakers. I would say that Peggy has a extensive experience in the tech industry. Currently, she's the CEO of Agility Robotics and the maker of the groundbreaking humanoid robots Digit. Prior to that, Peggy served as the CEO of Magic Leap, an EVP of Microsoft, and also a member of Qualcomm's executive committee. I would mention that Peggy was during her tenure in Microsoft, and she launched the corporate venture, Microsoft corporate venture M12. And this fund in just 3 years added more than 80 companies to the profile, which is so amazing, impressive. Throughout her career, Ms. Johnson has received extensive recognitions for her engineering and business success, including being named as Business Insider's most powerful female engineers in the US and being inducted into the Women in Technology Hall of Fame. It is truly my honor to have you today with us to share your insight in technology and robotics. Thank you, Becky.
Thank you, Henry. Thanks for having me. It's a great audience, and I'm looking forward to the discussion ahead.
Yes. I know we prepared some little clip about Agility Robotics. And would you want to bring it up, or maybe the crew can play with it?
Sure, they're going to play. Yeah, the video, that'd be great.
Hey Digit, what's cooking?
Nice, very impressive, right? This reminds me the Jensen Huang's keynote in GTC, and Digit is right next to him, featured in the center of stage.
It's good to be the only blue robot in a sea of black robots.
Yes,
so
it is.
You're right
it
next
is,
to
it
Jensen.
is. And add more colors into it, right?
Yeah, exactly.
So Peggy, I mean, you have, when I look at your career, you've been with large corporation, startups, or in the tech industry, but actually different sectors of the tech. If I look at Qualcomm, Microsoft, Magic Leap, now Agility Robotics. I'm just curious, what attracted you to the world of robotics, and what's exciting you in the humanoid robotics specifically?
So robotics, I've never worked specifically in the field in any of those. Obviously, Qualcomm's chips, Microsoft's enterprise software, augmented reality at Magic Leap. But actually, my initial interest in robotics went back to Qualcomm, where Paul Jacobs was CEO, and he was my boss. And he had received his PhD, had done his thesis at Berkeley in robotics.
I didn't know that.
Yeah.
I didn't know that Paul had robotics.
Interesting,
okay.
Yeah. And he talked about it all the time, but at that time, there weren't many places to go and work in that field. It was so early. But it did spark an interest, I would say, in all of us in the field. And when I eventually got the job, I sent him a text and I said, I got this job. It's like years after you got your PhD in that area. but it's finally happening. And that's, that was what drew me to agility. It's finally happening. The robots are working, and then it's just been supercharged with AI. And so the physical intelligence is, the movement, the locomotion of these humanoid robots. Very complex, very difficult to do. Agility has been working on that for 10 years as a company and 20 years as a tech team. They went back to their roots in both Carnegie Mellon and also in Oregon State, where actually Jensen went to as well.
Yeah.
So physical intelligence had progressed to the point where, agility had a humanoid that could walk around. And then AI brings the semantic intelligence, where you can now give a command. It can use computer vision to understand what's in front of it. You can say, go pick up this red box and put it over there on the blue shelf, and it understands and it can perform the task. So I think we're at this pivot point in time when we'll look back and say, do you remember we didn't used to have robots? Like kind of when search came, you say, remember when we used to have to look things up in dictionaries and encyclopedias? Yeah. This is the time. We are at that time, and from here forward, I think robots will increasingly become part of our lives, our work lives first, and then our home lives.
So when I think of robots, there are different type of robots, right? And what is special in humanoid robot? What's in terms of the form factor and what it can deliver?
Right. So there's all different kinds of robots, but just to picture for you what happens in, say, an Amazon logistics facility. If anyone's ever been in one, or frankly, any logistics facility, you go in and there's automation everywhere. And those are types of robots. There's conveyor belts, there's autonomous mobile robots, which look kind of like, a big square like this, and they can take packages down to the other end of the facility. There's put walls where things are pulled from the inventory and brought down, and then they're in these plastic bins called totes, and those get moved around. But that's been going on for, I would say, over the past 60 years. Automation has increasingly become part of those logistics facilities. But if you take it and say, okay, what are the Achilles heel? And you just sort of dim out all the automation, you still see there's a couple of people here and there. There's still people in the midst of all of this, because these islands of automation don't always work together. And so there's someone whose job is to take a plastic bin off of a conveyor belt and walk it over to what they call a put wall and stack it in there. Day after day, hour after hour. It's backbreaking work. It's dirty. It's repetitive. No one wants these jobs. But those are the sorts of jobs that still exist. Yeah. And they do because generally the human is maybe walking down the way the factories have been built, they're walking down an area that only a human can get through. And there's just still pieces of these facilities that humans have to be part of. And it's getting exasperated because we all want faster and faster delivery from Amazon. And so we want next day, we want 2-hour delivery. And that is making that problem, this labor shortage, actually grow from about 600,000 just a few years ago to over 1 million jobs today, just in that one field, just in logistics. So we have these sort of Achilles heels of automation where humans are, and that's where the company chose to focus their efforts and humanoid robots, to go where humans go and take the place of these dirty jobs. Actually, take the job that no one wants because they're unfilled for the most part.
Yeah. So, I mean, thank you for explaining that. So what I'm reading it here is, a lot of automation has been deployed in the factory logistics already, but there are still some, the part of the work need to be done by human.
Correct.
And humanoid robots will fill in the gap.
Yeah. And you could say, well, why do they have to look like humans? I would say they're human-centric. So we don't, for instance, necessarily think today you need 5 fingers for a lot of tasks. Generally in logistics, they're picking up bins and, you could pick those up just with a couple fingers.
Yes.
And the complexity of the human hand and 5 fingers is very high. So a lot of companies are focused on, well, it's got to be like a human. It actually doesn't, to do jobs that are needed today.
Yeah.
And so we're focused on what's the problem and how do we solve it for the need today. Over time, we can swap out the hands, or
Yeah.
they call them end effectors, and we can put a 5-finger hand on there, and we'll do all of those things. But it's not really needed for most jobs.
It is. I mean,
you
what I
think
see
about it.
about Digit is like it provides a platform, right?
Right.
You can change the I don't it's hand or whatever you call
Yeah,
it.
we can just call them hands.
Thing, yeah, and for specifically for different tasks.
Yeah.
And we all know that there has been incredible development in AI in the past couple years. In the GTS, Jensen announced that NVIDIA gonna launch their the robotic large foundational model, right? How do you see those AI development gonna impact robotic deployment and the development?
Definitely accelerate it. Yeah. We have, actually, he has, the program's called Project Groot.
Yes.
And so he's, going out to industry and asking for assistance in building this, because obviously large language models need data. There's a lot of data on other types of robots,
Yes.
Just robot arms or those AMRs, but there's very little data on humanoids. And so that's where someone like Agility could come in, because we've been deployed at customer sites for over 3 years. We've been gathering all that data. We have very unique data compared to everybody else in the field, because the company's been out there in the customer facilities, understanding what it takes to operate in a real commercial environment where you have to fit into the IT infrastructure. You have to understand the safety and the regulatory things. Even just to walk in the door, you have a bar that you have to meet. And that type of data turns out is pretty valuable to anyone building foundation models, but robotics foundation models and humanoid robotics foundation models, there's very little. So we have a real jump on that, a real advantage for Agility.
Yeah, it is true. I mean, as we discussed before, the way I see robotics has a lot of robots has been deployed out there, but not that many humanoid robots.
Correct, yeah.
And in order to develop a foundation model, you need data. I mean, a lot of data, as Professor Chen mentioned as well, right? And I think Agility really has a head start in this space. Yes. So, another way I look at how AI is gonna change robotics is it create a new human-machine interface. Before you need to program the robot so that robot do certain things. Now you can talk to it and interact in a different way. How do you view that gonna impact humanoid robot and Agility?
So we are building a multi-purpose robot, and that means we can train it on new skills while we're starting with logistics, because the need is great and there's an ROI there, and companies are paying us now to deploy these robots into their commercial facilities. That's where it starts. But because of AI, we've been able to collect a fairly significant data lake, bring in other data, so what we call the collective intelligence of the factory setting initially, but now off into other industries over time. And I can use that to teach Digit new skills. So already Digit, starting by just moving totes around, as they call them in factories, we've been able to teach Digit, by the way, is the name of our robot. We can teach Digit new skills, for instance, at a large national grocer that we've been working with that wants to restock at night. So we started with one thing. The data lake helped us train Digit on some new skills that were needed to work in that environment, and then off it will go. So we think of it as kind of a crawl, walk, run to get to eventually what will be robots in our homes. But it turns out homes are pretty crazy places.
Yeah,
There's a toy on the floor, the dog's laying on, in the way. And so a lot of consumer robots have struggled because the environment is not as structured as a factory. So we're starting the factory, learning a lot, and that's just compounding, and we will get to the point where we have them in our homes.
Yes. So I mean, people have been talking about humanoid robot and develop humanoid robot for a long time, right? It seems to me that agility is really ahead in terms of real deployment. Like why this is so hard?
Turns out it's pretty hard to balance, to walk. Humans, even like going up and down these steps, you are making so many calculations. How do I navigate that? You're not thinking about it. It's not front of mind, but it's happening. Unconsciously, you're just sort of navigating those steps. And when you think about a humanoid robot having to do the same thing, it's extremely challenging. So we've actually been using machine learning, reinforcement learning in Digit to improve the locomotion over the last 3 years or so since those tools started to really, accelerate and get better. And that's helped us do things like go up and down stairs, walk outside, navigate curbs. In fact, the team did some really interesting things. They watched a chicken. they had a sort of a plank, and the chicken was to run across it. But in the middle of the plank, it was just a piece of paper, and so it fell through, and there was solid ground underneath, but it had to right itself, and that's how they started training Digit on how to handle that sort of thing. So it's fascinating. It's the same sort of thing like in a factory. If Digit is carrying a tote, and let's say there's 10 pounds in there, we can throw another 10, 20 pounds in, and it can be in the shape of a ball. So it'll rotate inside that. And humans catch that. Like they understand how to, okay, I've got this, and they keep walking. Robot has to do the same thing. And so it's through simulations like that they were able to teach Digit how to really act just like a human, just like what we would do. But it's highly complex. And now that we have the AI tools that we do over the last year and a half, really, it's really helped to accelerate the progress.
It is. So when I look at problem, I really see it breaking into like one is hardware, one is software, right? And on the hardware side, you need to have the mechanical capability of doing certain things.
Right.
On the software side, you need to have the robot be able to perceive the environment and make the right decisions. I remember in the beginning of the month in the Gen AI Summit in San Fran, one of the keynote speakers from NVIDIA, they talk about NVIDIA's foundation models, robotics thing, right? And one of the comments he made is, the software progress so fast. Now the bottleneck goes to the hardware side because, it can, even the software can simulate and flip the pen, like I'm not gonna do is drop this, but there's no mechanical hand are able to do such things. Is this what you see as well, or?
It's interesting because I think we see a lot of new companies jumping into this space, and they're professing to be AI first. But I mean, we know what happens when we ask questions of the AI models now. It's not always quite right. So you can't, at this point in time, our thesis is you cannot rely on AI to control the robot. We are still using traditional methods to control the robot, which is, as you said, coding and doing simulations and understanding what the physics of the robot can do. And so I think that's a long road. There's really two schools of thought here. Do you get the physics of the robot, the hardware right first, and then use AI to accelerate? That's the path we're on. Or do you go AI first? The problem is there's no data, right? There's not a lot of data in that set yet. And so both methods have merit. We're on the first method. We've done this for 20 years, as I said, going back to their academic roots, the two founders, and they've made amazing gains in and progress in the physical side of the robot, and now we're using AI to accelerate it. But the robot has to be able to walk on its own. We're not tethered. One of the pictures showed tethered. That's because it's in the lab. And when they're testing things, you don't want the robot to fall over and over and break. But we're untethered. All compute's on board. Very much just like a human, and challenging.
So I want to double click on that. And what I'm hearing is, I understand RJ Robotics picked the first approach. And the reason of doing that is the AI first is because of the limit of the data, available data. It's not ready, or there's other concerns. Because I heard another school of thought is, in the case of humanoid robot, and human wants it to be like predictable. If the robot, especially humanoid robot, if the robot doing things unexpected, then it freaks people out, right?
Correct.
There's other like safety
a
side of it. It's trust issues, right?
Yeah.
And the question I have here is, is it a technical problem, or there's other concerns?
Well, there's definitely that concern, because this is the first time. I mean, an AMR that rolls down a factory floor, that's not a scary thing, right?
Even if
unless it runs over your toe.
Unless it hit me, I'm fine, right?
And it's a square thing. It's going up and down. But a humanoid, it's really interesting. When they first built Digit, it didn't have a head. There's no use really for a head, but we need to have arms and legs. And as we started to test it, it wasn't a comfortable situation when you introduce it to people who haven't worked around a humanoid robot. There's a headless creature walking towards you.
True.
And also a head tells you from a human what your intentions are, right? So if you're across the room and you turn and look at me, and I know, Henry's going to start walking toward me. Like there's psychologically cues that you get from humans that happen without you even understanding it. But when that thing walks in without a head, that's pretty creepy. So they put a head on it, and it's again, it's human centric. It's not meant to look like a human so much, but it's a sort of an oval shape, and it has eyes on it so that when it's looking your way, and there's a comforting feeling there that has gone over very well in the production facilities that we've put Digit into.
That is very true. I mean, this is a unique thing for humanoid. Right. For other type of robot, if it's just a robotic arm, you don't need that.
You don't care. Yeah, it's kind of an odd thing, but it's something we didn't really learn until we put it out there. In a lab, you're fine, right? The thing's never had a head. You put it out with a bunch of people, they can be taken aback. So.
Thank you. So now I would open up for questions and comments.
We talk about AI, we talk about robotics, and exactly as both Henry and Peggy mentioned, this is AI fueling everything, including robotics, is really what's happening now. How about the more human versus machine in terms of the labor workforce consideration? With a lot of robotics, we don't need that many human workers anymore. On the other hand, we do have human workers that continue to need jobs to pay for the food on the table. So as a company, do you think about that? Do you look into that? Or is that something that you leave it to others to worry about?
I mean, no, we worry about that because if there's not acceptance of the product, we don't have a future here. We have to have acceptance of that. But it's why we chose this area to focus on, because we could see that this labor shortage in logistics is just exasperating, getting worse over time. And it would seem to be the right entry point than maybe some other areas. We think of it as augmenting what humans can do. We heard a really interesting comment from the company that we started to deploy the humanoids at. And one of the gentlemen said, I used to be moving these crates. Now I'm controlling the robots. So we have some control software we call ARC that can control the fleet of robots, gives you metrics, how what the throughput is and all that type of thing. So this person said, I used to have a job and now I have a career, because they never thought they would enter into sort of a digital career that that he saw others having, but that was now his job. You are the person who's controlling the fleet of robots. It was an entirely new career for him, very satisfying, and so that's what we're trying to highlight, both that there's this large labor shortage and it's going to create new jobs for people. Someone has to manage all those robots. So
Yes.
it's going to be a theme, but I think we're prepared for that.
But I would add to that is I think Arjun mentioned in the morning we talk about with those automation robotics, a small country like Singapore only have 5 million people. It could make it become 50 million, 500 million because of those robotics and automation. Otherwise, a small country like Singapore would never get there. Yeah. Another question?
I have another one. So, have you also thought about food banks? Because there are a lot of people who donate food, especially in packages, but they always struggle to package them and put it to the homeless. So, have you also thought about putting these in food banks?
We haven't specifically. That's a great idea. As we gain more and more skills, the next skill is picking. Picking up. If you're at a food aggregation facility and you have to put a certain amount of food into a box, a robot could do that sort of thing. Pick up, a diverse set of food, package it up, possibly even deliver it. So those are the sorts of things that oftentimes we have just a shortage of labor in a place of great need that I think a humanoid can step in and really help out society.
Yeah, because what I've seen is it's very easy for anyone to donate food, but all the food banks, they struggle packaging those and sending it to the needy. And that's where all the corporate goes for like all those CSR events. We go and pack food but that's like rare. Right? It doesn't happen all the time. And they always struggle with food, and then that again gets wasted.
It gets wasted there because there's a shelf life there, and then it's gone. So those are the sorts of things that robots can step in and do. They don't get tired. They can work long hours. Ours just sort of back themselves into a recharge station, and after a bit they come back out and can keep working. They usually don't get hurt. They have very high reliability. So over time, I'm sure it will be introduced to more use cases like the one you just mentioned. It's a great one.
For the interest of time, this will be the last question. Yeah, Jeff, go ahead.
Thanks a lot for all the good questions by audience. Actually, just curious, and for the company, right? Have you thought about actually prioritizing the development of those kind of use cases where you're going to send humanoid robots to highly risky kind of places, like the kind of, for example, the polluted kind of nuclear reactor, the kind of scenario, which last time in Japan, they tried to send human being over there and a lot of people get cancer.
Yeah.
Have you been seriously considering this as part of a roadmap?
Absolutely. I mean, it's the perfect sort of use case to send in because they can image things. They can walk in places that humans can. And so we've definitely thought about that. In fact, we're starting to engage just over the last quarter with the US Navy, who has a set of use cases that they're interested in. The one thing we've done, though, is we've taken an anti-weaponization pledge. We will never put weapons onto our robots. And I mean, that's a whole world that we won't engage in at all. We'll engage with governments and defense agencies when it's, for training and that sort of thing, going into hazardous situations, but nothing beyond that.
So we come to the end of this session. I would thank you again, Peggy, for sharing the insight. This is an amazing video, and I really appreciate you sharing the vision of Azure Robotics. Thank you. Thank you so much.